Okay, here we are again, finishing up that review of exponential um, exponentials. I wanted to get to this piece and not have to rush through it. Scientific notation. Of course, you've encountered it in science class, and we want to spend a little bit of time with it. Being able to convert from scientific notation to standard notation. In other words, from, let's say, 6 times 10 to the third power to 6,000. So this would be standard notation, and this would be scientific notation, representing exactly the same number value. Knowing how to use scientific notation when you're multiplying and dividing, and how to use it successfully for approximating. In real life, that becomes very helpful. In fact, it's very helpful to you in a test situation when you're trying to answer the question, does it make sense? If you've been able to estimate your answer before you get to the end, it's very helpful. So we are going to spend some time here doing a few calculations. If we multiply 3.1 times 10, we are going to get a larger number. So we know that this decimal point has got to move this way, right, to give us 31. 10 to the negative 1, we've just been looking at that very thing in an earlier lesson. That's the same as saying 5.4 times 1/10, right? And here we know we're going to get a smaller number, so we're going to actually be moving our decimal point in that direction. So that will equal 0.54, which is smaller than 5.4. 10 to the 6th. Well, if we think of this as 1 times 10 to the 6th, what's going to happen? We're going to move it 1, 2, 3, 4, 5, 6 places. 0, 0, 0, 0, 0, 0. So we might want to write it with commas. When we get into some of these larger numbers, the commas are very helpful in helping us organize. How about this one? Well, if we think of this as 1 times 10 to the negative 4, we're going to get something smaller, so we're going to move this decimal point 1, 2, 3, 4 places in this direction. So we've got a decimal right here, 0, 0, 0. So 0 point, that's what that would be equal to. So write using exponential notation. Here we've got a 1 times 10. Oh, it didn't say scientific notation. All right, so forget the 1. 1 times anything is itself anyway. 10 how many times? Well, this is 10 one time, 2, 3, 4, 5, 6, 7, 8, 9. So 10 to the 9th power. Ten to the 9th power. How about this one? Here's a case where we're multiplying, right? And we've got the same base. Multiplying with the same base, what do we do with the exponents? Thank you. We add them. Multiplying with the same base, what do we do with the exponents? Add them. A -4 plus a -3, -7. Only you know I wouldn't leave it like that. I'd say 1/10⁷. Okay, so just a little review of exponentials. Scientific notation is always in this form. We have a, which is some number between 1 and up to, but not including, 10. And n is always an integer. Scientific notation, n has to be an integer, a has to be somewhere between 1 and up to 10. So what does that mean for us here? That means that this decimal point has got to move over to here. True? So we're going to write 4.5 times 10, and how many places did it move? 1, 2, 3, 4. 10 to the 4th. And this one, we want to have our decimal point right here. Right here. So that's going to have to move from where it is, 1, 2, 3, 4, 5. Now in this case it's getting smaller, so it's going to be 10 to a negative number. Let's see, we're going to have 3.68 times 10 to the -5. The distance from Earth to the Sun is 93 million miles. We want to write this in scientific notation, so we're going to be moving our decimal point 1, 2, 3, 4, 5, 6, 7 places. In scientific notation, we'd write that as 9.3. How many did I say? 1, 2, 3, 4, 5, 6, 7 times 10 to the 7th. Now please notice when we're making it larger, we've got a positive here. And when we're, well, I better be careful about this, how I say it. 9.3 times 10 to a, with a positive exponent is going to represent a very large number. 3.68 times 10 with a negative exponent is going to represent a very small number. Convert it to standard notation. So this is going to make a larger number, right? So we're going to go 1, 2, 3, 4 places. That would be 3, 8, comma, 38,700. And this one, what's going to happen with this one? When we multiply times 10 to the -3, it's actually going to become a smaller number. It's going to move 1, 2, 3. So it's going to be 0. Whoops, that's a point. 0.05876. Scientific notation. Your base is always 10. Your multiplier is going to be some number between 1 and 10, not including 10. Scientific notation. It is much easier to write something in scientific notation. Let's take a minute to work with our calculator. I think this might be a good time to do it. We'll bring it in. Whoops. Bring it in and look at some of these problems we were working on. let's test this and make sure it actually is 45,600. So we're going to turn this on, and I'm going to put in 4.5, and I'm going to say that's times, and I'm going to use parentheses here, 10 raised to the fourth power. Well, this would be very embarrassing if it turns out not to be 45,600. Cross your fingers. Oh, of course it didn't, because I didn't put in the right number to begin with. 4.56. Oh, I didn't even notice that. I made that, oops. Let's fix that. It's a good thing I went back. You kids are probably telling me, hey, Mrs. Turner, you forgot something rather important, which I did. How could I do that? Times 10 raised to the fourth power. There, that time it worked. That's why it's good to check, huh? And it's not just for students, it's also for the teacher. Let's try this one. 3.68. 3.68 times, I'm going to use parentheses, 10 raised to the power of, and I'm going to use parentheses for this too, minus 5. I don't know that I need to. Now close parentheses around that multiplier, and what am I supposed to get? 0.0000368. See what it did? Well, it took and put it into the notation that your calculator uses. So let's pay attention to that. Let's write what your calculator uses. Your calculator will write this as 3.68, and then it's going to put an E in here for engineering notation, I guess, or 10 to the exponent of -5. Let's go back and see what the calculator had on it. Did I write that correctly? Yeah. Oh, they use a very small e there. Okay. Okay, back to 93 million, 3 zeros, and then another 3 zeros. Enter. Now suppose I want to see that in scientific notation. I know there's something here that will allow me to do that. Let's look at math, numbers. Whoops, oh no, I remember what it is. Mode, I'm sorry. So I'm right now I'm in normal modes. I should change it. Okay, enter. Second, quit. Okay, let's try that again. Mode. I want to go to normal, scientific. Okay, now I'll go back. Quit. And hit enter. And it will put it into scientific notation, which is 9.3, my E standing for multiplied by 10 to the power of 7. Okay? Enough with the calculator. Okay, multiplying and dividing using scientific notation. Now, this, I think, is pretty straightforward. The way I think it's really good to think about it is all of these are being multiplied times each other. So you can think of this as just 4 factors. Of course, we know that this is a number in scientific notation, as is this one. But let's take the integers and put them first. 4.1 times 2, and then we'll take the base 10 and multiply these together. Now we know when we have the same base, which we do, what do we do with these exponents? Add them. So I end up with 8.2 times 10 to the 12th power. That's acceptable because my a, which is 8.2, is greater than 1 and less than 10. Try that again. I'm going to multiply the numbers. 9 times 4 gives me 36. And then I'm going to say times 10 to what power? That's right, to the 4th power. Is this in scientific notation? 36. Nope, it isn't. What's wrong? It should be 3.6. So we need to re-express this to get it back into scientific notation. 3.6 times. Now what did I just do? I made this smaller than it actually is, so this has to be increased. So I'm going to say 10 to the 5th power. Now if you get confused about that, take your calculator out and try it. How about this one? I'm going to look at this as 1.1 over 5.5 times, I've got these two bases of 10, so I can say 10, and it'll be 9 minus 6, or 10 to the 3rd. This is the same as 1/5. Times 10 to the 3rd. Now, scientific notation never has fractions here, so let's convert it to decimal. Is this in the proper form? A cannot be smaller than 1. It's supposed to be either equal to or greater than 1. So what have I got to do? I've actually got to make this number a little larger, which means the multiplier has to get a little smaller. We want to have it stay the same. So this is going to turn out to be 2 times 10 squared. You can see why this was really worth one more session. This would have been way too much. Estimating and approximating. Round to one significant digit to make a quick estimate. Okay, so one significant digit here would be 3, and that would be times 10 to the what? Okay, I did 1, 2, 3, 4 to the negative 4, right? So that would be that first number. The next one, let's call it 4, and that would be times 10 to the what? In this case, 10 to the 4th. And down below, we'll call this 6 times 10 to the what? 3, right? So let me put all my integers together. I'm going to have 3 times 4, which is 12 over 6. And for my base 10, I'm going to add these two, which gives me what? 0, 10 to the 0. Okay, so this is times 10 to the 0 divided by 10 to the third. Well, we certainly can straighten that out, can't we? What do we do when we've got the same base and a quotient? This is going to be times 10 to the negative. Here's, in scientific notation, we use the negatives a lot. We don't worry about it being down here. So 10 to the negative 3, and this would be 2. So we can make a pretty quick estimate here. And if you wanted to put it into standard form, it's actually not that difficult, is it? Whoops. That's difficult because I'm doing it incorrectly. So this would be getting smaller and smaller and smaller. So 1, 2, 3. So I'd have 0.002. I don't know what the actual answer is, but I could spend a minute to kind of estimate quickly what it should be. It's going to be some small number. Done. And your teacher says, thanks for your attention. We'll see you in class.